Hi, this is Dr. JMR. Today I would like to explain about empirical and molecular formula. What is empirical formula? Then what is molecular formula? Empirical formula represented by EF. Empirical formula represented by EF. Then molecular formula represented by MF. What is molecular formula? I would like to explain with an example. Molecular formula represents the number and type of atoms in a molecule of a chemical compound. For example, glucose. Molecular formula is C6H12O6. It contains 6 carbon atoms, 12 hydrogen atoms, then 6 oxygen atoms. Means this we can call it as molecular formula. One molecule of glucose contains 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Then what is empirical formula? Empirical formula means the simplest whole number ratio of various atoms present in a compound. For example, carbon dioxide. It contains one carbon atom, then two oxygen atoms. Suppose N2O4, it contains two nitrogens and four oxygen atoms. But simplest ratio you have to take, that is 1 is to 2. Nitrogen 1 and oxygen 2. Suppose you take C2H2 acetylene, it contains 2 is to 2. But empirical formula is C1 and H1, that is 1 is to 1. So like that, empirical formula represents the simplest whole number ratio of various atoms present in a compound. We'll take more examples. Suppose acetylene. Molecular formula is C2H2. Then simplest formula, empirical formula is CH. Then you take benzene. The molecular formula is C6H6. Then empirical formula CH. 1 is to 1. Ammonia. Molecular formula is NH3. Then empirical formula is also NH3 because 1 is to 3 ratio. Hydrogen N2H4. Then empirical formula is NH2. Next ribose. Molecular formula is C5H10. Then O5. Empirical formula is CH2O. Means you have to take simplest ratio. Means indirectly how many carbon atoms, how many oxygen atoms, or nitrogen, hydrogen. Generally, you have to take simplest ratio divided by 2 or 3 or 4, whatever it may be. Then, how to calculate this empirical formula or molecular formula based on the percentage calculation. Suppose, for example, compound X contains 69.9% of carbon, 6.86% of hydrogen, and remaining percentage. Sometimes what happened, he will give you 23.3 or remaining percentage is oxygen. How you have to do? Mainly by the addition of 69.3, then 6.86 plus then 23.3. The average, or you take addition of these three elements, then finally you will get a 100. If it is less than that, then don't worry, because the remaining percentage is impurity, because the total percentage is 100. Maybe it will come around 98. Don't worry about 2%. So what you have to do now? Determine the empirical formula of the compound. How you are going to calculate the empirical formula based on carbon, hydrogen, and oxygen percentage? First, you write one table by showing like this, means write element indirectly. Next, percentage composition of the element. Number of moles, smallest whole number ratio, mole ratio, simplest whole number ratio. First, you write the percentage given in the problem. In this problem, carbon percentage is given, that is 69.9%. Then hydrogen percent 6.86%. Then oxygen 23.3%. Next, you have to calculate the number of moles. Means number of moles. Mole means what? Given percentage, it is nothing but weight by atomic weight. You know carbon is 12, hydrogen 1, oxygen 16 are the atomic weights of the respective elements. Then given percentage, that is 69.9 divided by 12, because carbon atomic mass is 12. Then similarly, hydrogen 1, then oxygen 16, means given percentage divided by atomic weights, that is 12, 1 and 16. Calculate number of moles by dividing 69.9 divided by 12, you will get 5.825. Here, while calculating this value, you have to be careful because it value carry next step. Then you have to take at least minimum 2 digits or 3 digits. Then like that 6.86 divided by 1, 23.3 divided by 16. Then here you will get 1.45 like these values. So among these three, which one? Carbon number of moles, hydrogen number of moles, oxygen number of moles are calculated here. Then based on the values, select the least value. Select the least value, that is 1.45. So take that value and divide it by total carbon value, then hydrogen value, then oxygen value. Then here calculate the simplest ratio, whole number ratio of the carbon, hydrogen and oxygen. Here one thing, take that 1.45 divided by carbon value divided by 1.45. Then that is hydrogen, that is 6.86 divided by 1.45. Again here what happened, 1.45 divided by 1. Why? Here based on the lowest value means, so oxygen got with lowest value 1.45. Whatever it may be, suppose 3 elements are there, 4 elements are there, then you have to select the lowest value. Lowest value is 1.45. Then 1.45, 1.45, 1.45. Then here you will get a 4, 4.7. Then oxygen is 1. So here carbon, so 4, okay, no problem. How many carbon atoms means generally we'll say that is 4. Then what about hydrogen? That is 4.7. Then we can make it a round figure 4 or 5. No, not like that. Because zero point 0.7 is there. Then you have to give some priority. Means you have to multiply with one number to get whole number ratio. Means simplest whole number ratio. How? By multiplying 3. If you multiply with 3, then you will get 14.1. Similarly, you have to multiply to carbon as well as oxygen. Then here, carbon you got 4 into 3, then 12, okay, carbon 12 atoms are there. Then what about hydrogen? 4.7 into 3, then you will get 14.1. Then hydrogen 1 into 3, then you will get oxygen, 3 oxygen atoms are there. But here hydrogen, by multiplying 3, then you will get 14.1. At this stage, you can make it into 14, means round figure. So you can make it 14.1, then 14, nothing will happen. If it is 13.9, you can 14 like that. But if it is 0.2, 0.4, 0.5, 0.6, 0.7, 0.8, give some priority towards that value. So that is why we are multiplying not only 3, I'll show you next slide. Then you have to, based on the value, suppose if it is 4.5, then you have to multiply with 2 to get round figure. It is nothing but simplest whole number ratio. So like that here finally we got C12, H14, then oxygen 3. This we can call it as empirical formula. What is that? Empirical formula C12, H14, O3. So here like this, based on the percentage, based on the percentage, naturally what happened? Percentage divided by atomic weight. Based on that, then select the least value 1.45, then divided by 1.45, then you will get what you call 4, 4.7 and 1. Then you have to multiply with 3, then you will get a simplest whole number ratio. So finally, I would like to say decimal versus how we are going to multiply with number. If you will get 1.2 like that, then you have to multiply with 5 to get round figure, 6 something. So if it is 2.25, give some importance to that 0.25. Then you have to multiply with 4. If it is 1.33, then you have to multiply with 3. You will get 4. If it is 2.5, like this, 4.5, whatever it may be, 0.5, then you have to multiply with 2. So like this, what happen if it is 1.67 or 6, then you have to multiply with 3. Based on the values, that is decimals, into multiply with a 1, 2, 3, 4, 5 like that, then you will get a simplest whole number ratio. Means like this, when the number of moles for an element is a decimal. All the moles are multiplied by a simple integer to obtain whole number. So like this is about how to calculate the molecular as well as empirical formula. So first of all, again I would like to explain what is empirical and molecular formula. Just so here molecular formula and empirical formula, it is denoted by EF as well as MF. Then molecular formula means here one molecule of glucose contains C6H12O6, then 6 carbon atoms and 12 hydrogen atoms and 6 oxygen atoms. So what is empirical formula? It is the simplest whole number ratio of various atoms. Suppose you take carbon dioxide 1 is to 2, then 1 carbon, 2 oxygen atoms. Suppose if it is N2O4 hydrogen, then 1 is to 2, that is simplest. Then acetylene you take 1 is to 1. This is the empirical formula. Then based I gave some examples, acetylene, benzene, ammonia, like this empirical formula and molecular formula is actual formula. Then this is a simplest whole number ratio, that is based on that you will get empirical formulas. Acetylene, C2H2, CH, benzene, then CH, then NH3. You have to write like that only. Then N2H4, hydrogen NH2, then glucose, ribose, like this based on that. So if percentage is given, how you are going to calculate? Based on the percentage means give percentage of carbon, percentage of hydrogen, percentage of oxygen. So by the addition of these three values, then you will get 100. Sometimes he will give you remaining percentage oxygen like that. So determine the empirical formula. Then here, so first write the what you call table element, then a percentage composition of the element, number of molecules, then simplest whole number ratio like this. Then percentage. So percentage is given, percentage divided by the respective atomic weights, then you will get moles. So based on this, select only what you call lowest value, that is 1.45. So divided by 1.45, divided by 1.45, 1.45, then you will get one value 4, 4.7, then 1. Then here you have to multiply with the 3. Why? To get a simplest whole number ratio. So this is called empirical formula, that is C12H14, then O3. So sometimes how we have to multiply, I gave one example. So that is 0.2, then you have to multiply with 5, then 0.25 like this, 4, 3, 2, like this. So like this, do some problems. I gave one problem. A compound is found to contain 63.52% iron and 36.48% sulfur. So find its empirical formula. I gave one problem. Please do it. Okay.